All right, welcome back. You guys in the last section went through and did linear factor partial decomposition or partial fraction decomposition with linear factors. Well, in this case, we are going to kind of add on to that and do some quadratic factors along with some linear factors and kind of combining all of those. And this is a little bit more complicated. As you can see in the notes, there is only two problems because the first problem is going to take literally the whole page. And then the second one maybe will take a half, 3/4 of a page, something like that. But the first one's going to take like a forever distance. So I guess let's get moving and get on to it. So the bottom, the denominator, we can already see that we have x squared minus x and x squared plus 4. So I can take the x squared minus x, and that's x times x minus 1. So my denominator is actually x times x minus 1 times x squared plus 4. I'm able to break that apart and factor it a little bit. Okay, so now I want to find my fraction, my decomposition of this fraction. And how do I do that? I'm going to do the same thing as I did in the last video, or in the last section, right? I am going to say, okay, equals, all right, this is going to equal a over x with the first one, plus b over x minus 1, plus something over x squared plus 4, and this is where the change is. When you had a linear factor, which was x or x minus 1 or x minus 3 or whatever, all right, the numerator is always going to be a single letter, a or b, okay? But when I have a quadratic factor in my denominator, my numerator is going to be the next available letter, x plus d, or dx plus e, or whatever the next two available letters are. This is how I always am going to write this fraction. Because the exponent in my denominator always needs to be greater than the exponent in my numerator. So that's why there's no variables with the a and the b, whereas my numerator over here is going to be that. But because it's quadratic, I mean, you can think of like the exponent term, the degree is how many is what's up top. So I have one thing up top, now I have two, and now I write 2, I have to add an x in there. Okay? Or 1 degree lower, your top is always 1 degree lower than your bottom. That makes sense too, right? So now I want to take and find and multiply and get rid of my fractions. Okay, so I have 2x to the 3 minus 4x minus 8, which is equal to a times x minus 1 times x squared plus 4 plus b times x squared plus 4 plus cx plus d times x minus 1. Sorry, x minus 1. And in this case, you can let x be 0, which if you do that, my x's go, or my b's go, and my c and d's go, because those are all going to be 0. So I can solve this just for a. So I get, well, if I make x to be 0, I'm going to save some space here because this is going to be a long problem. This is 0 minus 8 equals a times negative 1 times 4. So that's negative 4. When I divide, I get a is equal to positive 2. Okay? Then, if you now notice, I can let x be 1. Because x is 1, this is the a's are going to cancel, the c's are going to cancel, and the d's actually. But then the b's are going to be left, and I can solve for that. So if I plug in 1, I get 2 minus 4 minus 8, which is negative 2, so negative 10, equals b times 1 times 5. And then therefore b is going to be equal to negative 2. So since b is equal to negative 2, a is equal to 2, that is nice. It makes my life like nice so far. So now what am I going to have to do? Well, I cannot let x be, 2 or 3 or some other number, because my c's and the d's are never going to be there while the a's and the b's cancel. So just like in the last video, I have to choose numbers. More so, I want to choose small numbers so that I can create what's called a system of equations. And you've done this in Algebra 2, system of equations. And so that I get two equations with c's and d's in them, and then I'm able to solve for one of them, find it out, and then solve for the other one. Okay? So that's what I'm going to do. I'm going to let x be -1. If x is -1, it's a small number, okay, and then that will leave my a's and b's there, but then I can plug in my a's and b's because I already know the value of them, right? So let's do that. Again, I'm going to save some space. So this is -1, so that's -2. Plus 4 is 4. 4 minus 8 is -4. Equals a times -2 times 5. Cool. And then plus b times -1 times 5. Plus, now see, it's -1, so now it's really minus c plus d times, this is -1 times, and then this is -2. Okay, so this is like that. So now, okay, let me, I guess, abbreviate a little bit. And then this is going to be -10a minus 5b plus, let's distribute, that's +2, so that's going to be actually a -2c, and then 2 times, that's plus 2d. Okay, hopefully we all are on the same page. Now I know what, did I do some math wrong? I think I did some math wrong. Let me check. X is -1. So if x is -1, this is, in my notes I have 6, so I got to come back and check. So 2 times -1 to the third minus 4 times -1 minus 8. So this is, ooh, this is wrong. So that's -2 plus 4 minus 8, so that is -6. Okay, so it's -6, not -4. Sorry. I think I said maybe -6. Maybe I didn't. I don't know. All right, cool. Well, now I know what A is, I know what B is, and I can plug in. So I get -6 is equal to, A is 2, so that's -20, plus 10, because that's -5 times -2, minus 2c plus 2d, and let's solve for c and d here. So this is -10. When I bring that over, it becomes a +4, equals -2c plus 2d. And now, let's divide everything by 2, just to be on the cool. So 2 is equal to -c plus d. All right? Fantastic. Okay, so this is 1. This is one equation that we're going to use. Well, now, because I have one equation, I want to find another one. So I'm going to let x be +2. So I'm going to let x be +2. Again, that's then going to give me another equation with c's and d's. And then I'm going to be able to use a system to solve for c and d. Now, you can use whatever you want to use. Like, if you want to make x to be 100, like, be my guest, go ahead. I wouldn't recommend that, but if you want to take 3 hours to solve a problem, go ahead. So I make x to be 2. Okay, I get 2, 4, 8, 16 minus 8 minus 8. Well, that's 0. Okay, so the left-hand side is 0. That makes it nice. Equals a times, that's 2 times 2 minus 1 is 1. Times 4 plus 4 is 8, plus b times 2 times 8, plus c times 2, or 2c, plus d, times 2 times 1. So this is 0 equals 8a plus 16b plus 4c plus 2d. Now I plug in a's and b's. So 0 equals 8 times a is 2, so that's 16. B is -2, so that's minus 32, plus 4c plus 2d. And then 4c plus 2d is equal to positive 16 when I bring that over. So it's going to be positive 16 over here. Let's divide by 2, and I get 8 equals 2c plus d. Okay, so now I have another equation that is a system that has two variables unknown in it. So I'm going to take both of those equations, 8 equals 2c plus d, and then I have 2 equals -c plus d, and I'm going to solve this using elimination or substitution, however you want to. I'm going to use it as elimination, so I'm going to eliminate my d's. That means I'm going to change this to a minus, to a plus, to a minus, and then I'm going to add them together. So that's 0, this is 3c, and this is 6, so c is equal to 2. When I plug back in 2, so we'll go here, okay? So that's 2 equals -2 plus d, and then d is equal to 4. So c is 2, d is now 4. Great. What does that actually mean? Well, that means that these letters up here are now going to be filled in. Okay, so let me clean this up a little bit. And yeah, let me, I guess, write some new stuff there. Blue's Clues. Hopefully you're like watching me doing this. It's like therapeutic, right? Like therapeutic. You're like, whoa, this guy's erasing. This is cool. Okay, let's get into some math. So now the A we know. Shoot, where the heck was A? Dang it, I forgot what A was. I'm just kidding. A was 2. Okay, so we get 2 over x. Let me do this. We'll do this. So this is all the integral. So 2 times the integral of 1 over x dx plus, we know b was -2, so actually it's a -2 here, times the integral of 1 over x minus 1 dx. C we know is +2, and we know d is 4. So plus the integral 2x plus 4 over x squared plus 4. Okay. Oh, all right, let's do this. Let's do awesome, awesome, awesome sauce. So now, this here, okay, this first integral is going to be 2 times the ln of the absolute value of x minus 2 times ln of the absolute value of x minus 1. Like, that's easy. We can do that linear factors all day long without doing use substitution. But now I'm gonna be in need of use substitution. And here's why. Here's what I'm gonna do. Well, I guess before I do use substitution, this is dx, let's take this here, okay? Let's take that there, and let's kind of mess around with that a little bit before I do some use substitution. And you're like, what are you talking about, mess around with that? Mess around. I can't mess around. It's math class. Well, yeah, I can. So, because my numerator is a binomial, my denominator is a binomial, but what if I said this is equivalent to 2x over x squared, oops, that's supposed to be x squared plus 4 dx, plus the integral of 4 over x squared plus 4 dx. Is that the same thing? Well, because they have the same denominator, I add the numerators up, and yeah, that's actually the same thing. So I'm going to delete all of this stuff, and I'm going to say that it's going to be plus the integral of 2x over x squared plus 4 dx plus 4 times the integral of 1 over x squared plus 4. All right, cool, cool, cool. X squared plus 4 dx. Well, now, if you look at this one here, I'm going to have to do use substitution. X squared plus 4, du is 2x dx, and then therefore the dx's are going to cancel. So then you're going to get 1 over u du. Okay, so that's going to be 1 over u, which is the natural log of the absolute value of u, x squared plus 4. Okay, so that one's easy. But now we're in for some rude awakening, because this 1 over x squared plus 4 is gonna suck, because this is more trig stuff that we have to understand and remember. So I'm gonna make u, well, okay, let me back up and I'll ask why do we know it's trig? If I look at my denominator, this looks like u squared plus a squared, where u is x and a is 2. And this here, in my denominator, is like arctangent, if you remember. Okay? So we're going to have to use some arctangent. So I'm going to say u is equal to x, and then therefore du is equal to dx. Okay? So it's just a straight switch. And now, what am I going to get? Well, because a is 2, and so a is 2, right? Square root of 4 is 2, all right? This here is something I have to remember how to do. So an arctangent, okay, is u over a, all right? So I got u and I got a, but when I actually integrate that, I got u, which is x, a, which is 2, fantastic. But then I have to divide by 2, or multiply by the 1 over a. So multiply by 1 over a. 1 over a. And so this here is going to be my answer for this whole fraction. I got 2 ln absolute value of x minus 2 ln absolute value of x minus 2 plus ln absolute value of x squared plus 4 plus the 1 over a. Well, it's now, the 4 is still there, like this 4 is still there, times now the antiderivative of all of this, which was 1 over 2 arctan of x over 2 plus some value of c. And you can, take that away and make it a 2. That's fine, doesn't really matter. But that is your answer, and that's how you're supposed to do it. And that is going to suck. We need practice. Practice, 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 practice! Let's go on to the last one, because the last one's a little shorter anyway. All right? Now, we have repeated quadratic factors. Very similarly to repeated linear factors, where I need to start with, or I go, like this power is 2, so I need a over x squared plus 2 to the first power, plus, I'm sorry, not a, because it's quadratic, I need ax plus b, plus cx plus d over x squared plus 2 to the 2 power. And you would keep going up, so if this was like the third power, then you would do ex plus f over x squared plus 2 to the third power. And you would keep going up as well. Okay, so now let's find out what I get. I got x to the, or 8x to the third plus 13x equals ax plus b times x squared plus 2, only one of them because I only need one for this fraction, plus cx plus d. Well, I don't need any x squared plus 2's on this fraction, so I'm good to go there, actually. Okay, so now how do I do this? I'm going to multiply all this out. So I get 8x to the 3 plus 13x equals, I can't let x choose a number because x squared plus 2 will never be negative, and that will never, ever, 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 ever give me a 0. Okay, it will never give me a 0, so that really defeats the purpose of anything, and that doesn't help really. So I am going to multiply everything out like I said, so I get ax to the 3 plus, well, it's 2ax plus bx squared plus 2b plus cx plus d. Okay, so that's what I get. And what I am going to do is a little manipulation with my equation, both sides of the equation. Now, what you're going to understand, hopefully you understand this piece, but what I can do with this 8x to the third plus 13x is that I can take it as 8x to the 3 plus 0x squared plus 13x plus 0. Like, I didn't change the value. I just put a 0 in place of the x squared, like that quadratic piece that I don't have over here. And I put a 0 where the constant is at the end. Equals, now I am going to kind of line this up in the same direction. So I have a squared term here, so I'm going to make it so that it's plus bx squared. I have a linear term x and another linear term x here. So if I factor out the x, I'm left with 2a plus c times x. Okay, I factored out that x. And then plus, well, b is just a number, and d is also a number. So that's 2b plus d. Okay, and I'm going to put that there. And so this is my cubic, this is my quadratic, this is my linear stuff, and this is my just constant at the end. And how does that help me? Well, it helps me because the left side of this equation is also in the same form. So if the left-hand side has to equal the right-hand side, then we know that the 8x squared has to equal if 8x to the third has to equal ax to the third. Well, how does that equal? That means that a has to be 8. And then the bx squared has to equal the 0x squared. Well, then that means that b has to be 0. And then this 13 has to be equal to 2a plus c. But I already know that a is 8, so 13 is equal to 16 plus c, and therefore c is negative 3. And then this 0, so let's do 1, 2, 3, 1, 2, 3. This 0, 1, 2, 3, 4, has to be equal to 2b plus d. So 0 is equal to 2b plus d. And then b is 0, so that's 0. So then d is also going to be 0. It's a little manipulation. You got to think about it a little bit. But I'm able to do that because both sides have to be the same values. So if I have it in the same general form, I'm able to just take the coefficients and find out what they are very easily that way. And so now let's split this up. And so my integral of 8x to the 3 plus 13x over x squared plus 2 squared dx, that's equal to 8x over x squared plus 2, because b is 0, dx, plus the integral of negative 3x, because d is also 0, over x squared plus 2 squared dx. So I split that up in that direction, in that way. Now, okay, now I am going to say, well, let's make u my x squared plus 2. My du is 2x dx. So these are going to cancel, but I'm going to be left with a 4 out front. And so this is the same as 4 integral 1 over u du. Well, that's equal to 4 times ln of the absolute value of u, which is x squared plus 2. Okay, so that's easy. So that one's good. The second one is the one we got to worry about. And how do I worry about the second one? Well, that's another u substitution. I'm going to make u x squared plus 2, and du is equal to 2x dx. So the x's are going to cancel, but then I'm going to have to pull out a negative 3 halves. So I'm going to pull out a negative 3 halves. So it's going to be minus 3 halves times the integral of 1 over u squared, which is u to the negative 2 du. Okay? And u to the negative 2, right, is u to the negative 1 divided by negative 1. So this is going to be minus 3 halves times u, which is x squared plus 2, to the negative 1 power. Divided by negative 1, but that just means that I'd make this a plus sign, right? So I make that a plus sign, trying to get my eraser. Here we go. So this is just a plus sign. So plus 3 halves times x squared plus 2 to the negative 1. If you wanted to put this in your denominator, you can, but don't forget about your plus c at the end. So that one wasn't too bad. We just had to think about that a little bit. This here is going to be probably the hardest part, making sure you're able to understand when you do that, why you do that, and if you have questions, please ask. But that is it for this video, which is partial fraction decomposition with quadratic factors. Deuces.